So welcome to Accession Center. So today I'm going to look at a question from Science Service 2021 Science Paper 1 GCE question B5. So now this question is based on wave properties. But before we proceed, first let's define what is a wave. And then we also look at some terms that we use in waves. And then we also talk about the different types of waves. So now, a wave itself is defined as a form of energy that is distributed from one place to another and it carries energy. So now, there are different examples of waves. Some of these we have light wave, sound wave, we have also electromagnetic wave, etc. Apart from that, we have also different types of waveform. But our main focus are going to look at only on transverse wave and also longitudinal wave. So now, to put things in order, or maybe not waste much of the time. So now, the type of wave that we have here is known as a transverse wave. Now, a transverse wave is defined as a form of wave in which the vibration of the particles are perpendicular to the direction of the wave travels. So now, there are some things that we need to note on this wave. We have one, the highest point of the wave, it is known as the crest. And then now the lowest point is known as a trough. Now, apart from this, the minimum distance that a wave repeats itself, we call it as the wavelength, which is represented by the symbol lambda. But without wasting much of the time now, let's look at this question. So, figure B5.1 shows the transverse wave. We have this transverse wave. Now, the first question, find the number of waves in figure B5.1. So now, for you to determine the number of waves, at this point, you need also to look at some points, which can actually help you. Now, to determine the number of waves, at this point, we're going to look at a complete circle. Now, a complete circle can be the circle between the crest and the trough, or between the crest, or trough and trough. Therefore, the number of waves we can determine here, we just count a complete circle. So now a complete circle involves a crest and a trough. So therefore, when we move in this motion, we have one wave. Again, we have second, third, fourth, and then one there, fifth. Therefore, the number of waves that we have here, we have 5 waves. That is our answer for A. Let's proceed. B. What is the amplitude of the wave generated in figure above? So now, the amplitude is defined as the maximum displacement that a particle moves from the resting position. Therefore, a distance from the line of zero disturbance up to this point. It is known as the amplitude. Now, amplitude is defined as, let me repeat again, is defined as the maximum displacement that a wave moves from the resting position. Therefore, our amplitude here it is 5 meters. Mind you, amplitude, the SI unit that we use for amplitude, they are in meters. Therefore, our answer here it is 5 meters. That is our amplitude. Now let's proceed. C, calculate the speed of the wave if the number of waves in figure B5.1 are produced in 2 seconds. Then now, this question we can do it in 2 ways. We can also use the formula for speed is equal to distance over time. Or we can even say that wave speed is equal to frequency times wavelength. That is our formula. Now, let's determine what we have in our question. Now, the first one, here, if you correct our data, what we have? So, the frequency, we don't have. Wavelength, we don't have. The wave speed as well, this is what we're looking for. So now, before we proceed, first, we determine our wavelength and so our frequency and our wavelength. Then we can say that frequency is equal to the number of waves over time. And then frequency itself is defined as the number of complete waves produced per second. And then at this point, we are going to use this formula for us to determine the the frequency. Now let's get our data here, what we have. The number of waves we have, it is 5 waves. The time we have been given in the question. The time given in the question, it is 2 seconds. And then our frequency, it is a known. So before we proceed with this formula first, I said we have to determine our frequency. After determining our frequency, then we are going to determine our wavelength. That's where now we can proceed. Then we say that frequency is equal to the number of waves given. We have 5. We divide them with the time, which is what? 2 seconds. Frequency is equal to 2 into that. What is our answer? 2.5 hertz. That is our frequency, or which can also be written as 2.5 seconds to the power negative 1. Like that. It's the same. And then now after determining our frequency, then now we can determine our wavelength. Now, wavelength is equal to. Now, determining our wavelength, we're going to do this. Let me just give you another formula. We are going to say the total distance over the total number of waves. Now, if you check it, the total distance, it is what? 6, which is in meters. So, we're going to say 60 meters over the total number of waves. The number that we have, the number of waves that we have here, it is 5. So, if you divide this into that, what is our answer? 1.2 meters. Then now we have our variables for frequency. We have also our variables for wavelength. Then now we can proceed. We can now say that wave speed is equal to frequency times wavelength. Therefore, we say that wave speed is equal to frequency 2.5 hertz by 1.2 meters. If you multiply there, our answer that we're getting is 3.0 meters per second. Awesome. Thank you for joining us. See you next time.